I guess we need to wait a bit for a couple more people. Uh, okay, then let's start our lecture. So I guess there are 3 to 4 people now on the website. And today we'll make an introduction to this course that will run for about 6 weeks. And we will start with Python tutorials on what's with really basic syntax construction and the basic variables and functions of it. And first, let me show the program that we'll be going over. So as you have noticed in our pitch materials, this 6 course will be covering about 11 topics in total. First will be basic types, environment, variables. Then we'll come to collections as a list of tuples and dictionaries and sets. And then on day 2, I think we'll cover functions, decorators, and generators in order to make efficient function calls. And of course, we'll cover classes, which is a must basically for object-oriented programming. And classes are basically enough abstract objects where you can add some attributes and which are kind of properties, let's say in JavaScript. And then there are methods upon these attributes to change them. And we will cover them in topics with some sort of examples as well. In terms of object-oriented programming, there are 3 main things that you need to understand as a programmer. First, there is an inheritance, abstraction, and actually encapsulation. And basically, these 3 topics will cover more. There is a concept of solid framework, which is tightly related to OOP, but not but extending some of its applications and do some more internal things like errors and magics. And besides these topics, we not only will cover the kind of theory, but we will do practical, let's say, applications of our concepts. And the first thing that I want to show to you is GitHub project that you will build over 1 month, basically, 1.5. And yesterday I started a small repo related to this course. So now private one, but it will be shared to those who join. And we have created our first branch, and it's under main logo. And we got a couple of scripts that we'll cover today. In order to actually start programming, you need to have several skills which are related to console programming with Bash. And on Windows, it's a bit of different, but largely similar in terms of concepts. And also, you would need to learn Git, of course. Git is let's say, programming interface that help you exchange files for a shared development and collaborative work on a single project. So imagine there is one person in Europe and another, I don't know, United States or elsewhere, or in Australia or other countries in Asia. And then in order for them to work on a single projects from the remote servers, Git-like systems are very popular. There is a bunch of them. There is Bitbucket, there is GitLab, there is GitHub. But now GitHub is kind of 80% of the market, and it's most popular, and that's what we use. Let me show the repo. So for example, if you go to the main, let's say, main branch, and so for example, we will be in our Python course, it's on our GitHub, and you see the files here our kind of environment that we are now just building. And usually when you work with a Git repository, you need to add a README, which is a kind of a basic document that tells you about as a description of what you do, and basically the main highlights you put here. Now it's just only descriptions, but we will add also, of course, the programming scripts, and in order to do that, you should do something like this, and you could do 1, 2, 3, and 1, 2, 3, and then, for example, cd some folder, etc. Yeah, so this kind of scripts is to highlight the code. And so, yeah, let's start. So first thing first, we need to kind of understand the base types in Python. Yeah. In Python, the basic types are not that different from other interpreted languages like JavaScript. And the main difference from compiled languages like Java or Golang, or let's say C, is that even the basic types have their own methods. So let me show an example. So for example, if you say print and say print number, and then it will give you an output. And by the way, on this first lecture, I think we will not use file system at this stage. Of course, we could and we will, but now I actually suggest you to use a Colab environment. Google Colab environment is a really powerful framework that you could use for many things. It's not only about actually Python, it's more about data science and deep neural networks, where you could build a lot of things out of scratch and without actually deploying a new thing. For example, we will make a first lecture here and we will download the file. And this Google Colab is an environment pre-built. It has about 40 gigabytes of hard disk and about 10 gigabytes of RAM, which is given to you for free. And you don't need to pay for that. It's free of charge. The only thing, the disk is not persistent. What I mean is that any file that you upload are deleted upon the exit from the session. And that's why you need to take care of it. So if you want to save some work, especially in terms of files, you need to download them. Yeah. But at this stage, we're not going to work with any database or persistent files, and that's why we'll go easy. And so let's try to do our first code things. And this is about numbers. Yeah, this is the basic things about numbers. And let's say we can actually run it as one cell. Yeah. So as you see, we have an output that has been given after these statements. And in terms of number, Python differentiates between two variations of it, like floats and numbers, integers. And so, for example, if you say print type of num, it says class integer, yeah? And if you say with a dot, then Python automatically detects that it's a float, and that's why it gives you a class of float, yeah? Python can also has inbuilt support for complex numbers. So if you put J after a second number, it infers that you are dealing with the complex numbers. And that's why it has a real part and imaginary part at the same time, that it kind of breaks down itself. And yeah, so this is about the numbers that I wanted to show a bit of you. Now, yeah, this is an interesting part, but I would tell it a bit later, yeah. Of course, when you operate a program, you need to kind of define operators. They could be arithmetic, logical, or Boolean, yeah. And for example, these three things are really simple, and they are arithmetic operators, where you could define the first basic things that you see in school, but it's really easily done in Python with these kind of commands. So we have we we can put it's a power function with a double asterisk, and double hyphen is division, but integer division, yeah, integer division. And again, coming to our main point, so for example, yeah, let's say you say num.real, yeah. What it makes under the hood is that it calls real method on the num class, yeah, on the num object, let's say. So if a num is just a simple object, then how can we call a method on it? The thing is, in Python, the primitive numbers, the primitive variables are not that primitive in the sense that they are basically objects. They are classes that has their own attributes and methods, and that's why they actually encapsulate a lot of information. So it's not only a value that is stored. For example, those who coming from C or C++, they know that a basic primitive like number or float is just it. Like interpreter or compiler allocates only a specific cell of specific size for that variable, and that's it. There is nothing else. But in languages like JavaScript and Python, it works a bit differently. So even a simple number, it is actually an object with a lot of things on board. Yeah. And for example, in this case, it has a real method, it has imaginary method, and actually we could extend this list. Yeah. And yeah. So for example, if you look at this description that I put down here, so it says that under the hood, the Python use a E object of type struct, and it actually inherits from Py object and Py size. And there is more bit of information of how garbage collection works, but I think I will not load you this information at the first lecture from the very start. But yeah, garbage collection in Python is very straightforward. It is counting the number of references to the variables. And as long as there are no references, the interpreter understands that we can clean this variable. And if there is no other variable referring to it, it will be not in the namespace. Yeah. Logical variables are quite straightforward. So you could use like smaller or bigger or with an equal sign, and the booleans work also similarly. Not much of complications. The only interesting thing that you can combine a number of them in a single line syntaxes like this, and it works without any errors. For example, if you try something like this, we should initiate x and y. Let's say, no, let's make it a boolean, right? Boolean. For example, it's just to make it work. And yeah, so it's a single line syntaxes, which is kind of interesting, right? And then we are coming to the concepts of libraries. So as many other languages, you can import libraries from other files or modules, and it is the power of interpreted languages, or actually any other language, that you do not have to write all your code from scratch. In 98% of cases, you would use other libraries and just you add a couple of sentences in order to optimize or like feed specific variables. But mostly you don't write this kind of things. I mean, you don't write the libraries unless you have 3 to 4 years of experience. Then you start to contribute to the repositories and start to actually change the existing libraries. But for a year or two, just you would most likely be a simple user, not contributor to this kind of repositories. And how now we're coming to the strings. And the string basically is a sequence of characters, right? As and like in other languages, and you can iterate them by letters. So let's do this in a very like straightforward manner. So if you call a simple for loop on this kind of, let's say, phrase that I have started, and yeah, it does it for you. Yeah. So basically, coming to the for loops, it's a control flow. Yeah, and I would cover it a bit later, but let me show first how we can combine our template strings with variables, how to inject into the, let's say, string expressions, some specific variables. And you can do it in 4 ways in Python. And actually, there is not much of difference in terms of efficiency because they're kind of largely the same. And it's more matter of, I don't know, syntaxes or personal preferences. And frankly, I use the third method most often because it's kind of most explicit. Yeah. So you name the variables and you explicit in specific points, and that's why it's easy to track later on when you try to debug your own code. And then commenting, yeah, it's, of course, this is also thing that you should learn first. So single line comments is like just a simple hash, and if you put, for example, a sign like this, it will be multi-line commenting, yeah. So like three apostrophes, it's multi-line. And now next is a bytes. So what is a byte? Byte is a combination of 8 bits, right? So it's 256 size. I mean, each bit is 2 bits. 2 to the power 8 is we are getting 256, and this is a basic unit in many languages, including Python. And you can express actually any string as a binary string and vice versa. But for example, if you are working with, let's say, English, it works in ASCII code, which is kind of standard. But if you work with any other languages like Swedish, French, Italian, Chinese, or whatever, then you need to use UTF-8 because they have a lot of more characters that are not included in the basic 28 letters of English, right? And that's why you switch to UTF-8, and this is a thing that we have to do when we work with other languages as well. Non-type is a specific class which is unique, and its only value that is accepting is none. And what is none? Maybe if you work with other languages like C, Java, or JavaScript, there is a notion of null, which means that either a variable is not initiated, or maybe it is initiated but not assigned any value. So the equivalent of null in other languages is none in Python. And so here is an example of it, how it goes. So it's really straightforward. In this case, we are trying to print something if we have the value, but if we don't, we say that we have nothing, and this is what we got here. So actually, the result is as expected. And now, let's come to our for loops. For loops is a control flow type, and it basically iterates through an iterable object. And what is iterable and what is not, we will come to it. It comes to notion of classes and whether or not there is iter method implemented in the class, etc. It's actually a topic of next class. This is just the first refresh and warm-up introduction this time, and that's why I will not go deeper into iterators today. But in terms of the for loop, yeah, it's a basic construct like for I in range. The range operator in Python is very handy, and actually it's not available, for example, in JavaScript, and sometimes you miss it. And the idea that you feed an integer and it gives you an array of integers from 0 up to this integer, but not including. So for example, if you run it, you get 0, 1, 2. It's up to 3, and it's really cool when you want to iterate through letters or some abstracts. When you work in practice, you would see that it's very, very useful. And then we come to the idea, we are now closing down the basic types overview, and now we are coming while is kind of similar, where you put the condition, and if it works, you do something. If not, you exit. Yeah. So actually, I would not spend much time on it, and you could actually consult any other material online as well. So we're closing with me as well. And if else, yeah, I think it's also very straightforward. Probably not so much of need to stop on this much, but the interesting thing is that not only you can do if else, but also you could, if there are some additional ones, the actually Python expects you to put elif rather than else if, for example, like in other languages. So this is the only gotcha about Python. And yeah, the models. The models are very important part of actually scalable programming, because you need to import multiple files, and then in order to aggregate them, you build modules from files. Yeah. So for example, in this case, this is an exporting basically. This is an exporting model. Actually, what is a model? Yeah, model is any file with Py extension that can export any variable or function. So in this case, we are exporting add function and a Fibo function. Fibo function is a Fibonacci sequence here that is accepting one integer argument, and then it's generating the Fibonacci sequence up to that number, starting from 1, yeah, or actually even from 0. So, for example, we have another program which is tries to import that model. Yeah, you could do it in two ways. First is just say import imported. So imported is referring to this file. This is a kind of most straightforward, but then in this case, you would actually import the whole file overall, whatever there is there. Imagine it's like 300 line file, then you would import everything of it, which may not be good, because sometimes you need just to import some specific segments or specific functions. And that's why this is where from comes. If you say from imported and import specific ones, you can target specific functions in order to import from other models, right? There is also a notion of packages. So what is a package? Package is any basically folder, for example, like GitHub in our case, where there are multiple Py files, but the main idea is that from a single folder, from a single package, there could be only one file that is exporting. Yeah, so you would have to define usually a file like this. By convention, we call it init with double underscores, and this is a file that could be completely empty, but this would be a reference file, and that would be searched by other packages if they want to understand, hey, we want to import some models from this, but which ones? In order for packages not to parse every given file in the package, they look only in the specific init.py file in order to understand what is exported. Yeah. So it's kind of a summary script that tells you which specific functions from which modules are exported. And we will not cover much of this, but you should know it just as a concept. So generally, this is how package system and model system works in Python. And regarding the scripts that we have developed, yeah, so let's go to Git now. So in Git, I have already created a project, and each one of you, when we will start building it, you do your own project. It will be related to web requests. We will parse data from the internet. We will get the data, process data, and then even deploy on very straightforward, let's say, front end. But in this case, it will be like really not extensive what we do, because it's just introductory course, right? And but let's do one thing. We did lecture 1, and I will just show you how the Git system works basically for So for example, if it's the first time you see it, so this is how it works, and it's not very actually difficult. Yes. So for example, if you go to downloads that we have just created, and then if you put it here. So what's Git? As I said, Git is a file exchange system. So it has an index file that is tracking all the files that is in the repository. And there are basically 3 commands that you would use most of your career when you work. So first you say git add. And by git adding, actually Git starts to register all the files that have been, that it detects into a single index file. There is index tree, yeah? There is index tree. Imagine it is basically a tree. And for example, when you create a new file, what Git does, it just adds a leaf to the tree, yeah? Each file is a leaf on the tree. And when you create an index tree, it's generating these indexes, yeah? Like it just has to know, like, it's like a, I don't know, imagine a building and there are different rooms. So it's a kind of room plan. So which room, which floor, right? Then there is git commit command. Git commit command is a bit different. So let's say it's in the repo. It expects to give you a comment like, hey, what did you do with this tree? Yeah. And you say, I added leaf 2 in order for, let's say, branch 2 be bigger or to make it more interesting. So probably I painted this leaf with color red. So this kind of comments you put here and you add. And then Git starts to understand at what point you added which leaf with what purpose. So that when another programming starts to read your code, he completely understands what you did step by step. Because if you are building a 10,000 line code with about 100 developers, and if nobody comments, it's impossible to track what everybody does, right? But with this kind of approach, everybody is actually seeing what else is doing, right? So it's very transparent and it's very actually efficient because not only the supervisors can see what others do, but also your peers, because most of your time you will be speaking to your peers rather than supervisors. So we added our changes that we wanted, and now we need to push it, yeah? So basically, there is an idea of a remote. What's remote? Remote is a branch, is a remote